It only takes a crack 2 millimeters wide, not in your skin, in the wall beside you. On Earth, nature forgives our mistakes. It's an open system. But out here, every leak matters. If you lose a drop of water or a breath of air, it's gone forever. The base dies by subtraction. Apollo was about brief surface missions, but NASA's Artemis program is about learning how to stay. And to survive in the extreme environment of the Lunar South Pole, you can't just rely on cargo rockets. Shipping every drop of water and tank of oxygen from Earth isn't a long-term plan. It's an expiration date. To survive, we have to shrink Earth's entire ecosystem and pack it into a metal tube. A real moon base is not just a building, it is a fragile, artificial organism, a hybrid survival system that starts with machines and slowly grows into a living ecology. And just like a human body, it has to breathe, circulate, and digest, or it dies. Before this organism can breathe, it needs a pulse. At the Lunar South Pole, light skims the horizon, shadows stay black, and temperature becomes a survival problem. In the permanent shadows, it plunges to minus 200 degrees Celsius. Without a constant flow of energy, the base would quickly lose thermal control and freeze. Some ridges can catch sunlight for long stretches, making towering solar arrays useful. But useful is not the same as reliable. To survive the deep, unpredictable shadows, a lunar base requires a continuous nuclear heartbeat, a microfission reactor. Together, they pump electricity through the habitat. But generating all that power creates a second, deadly problem: waste heat. Outside the habitat, there is no air to carry heat away. With computers, pumps, and human bodies constantly working inside, the base could literally cook itself. It has to sweat. It must push that excess heat out into massive external radiators. And this is where the organism meets its first environmental enemy, lunar dust. It clings to the radiators like a parasite, a razor-sharp, electrostatically charged contaminant that chokes their ability to release heat. If the dust isn't cleared, the metabolism overheats, and a fever in a place with no hospital is a death sentence. With the temperature stable, the organism takes its first breath. Initially, a lunar habitat relies entirely on mechanical lungs to scrub carbon dioxide from the air. It keeps you alive, but it's loud, maintenance-heavy, and constantly depends on replacement hardware from Earth. To survive long-term, the base must evolve. The machines won't disappear, but over time, biology will begin to share the work. Engineers are developing bioreactors filled with microalgae, like spirulina. They devour carbon dioxide, breathe out oxygen, and multiply. For the first time, the base isn't just running, it's growing. But every time an airlock opens, the outside world tries to force its way in. Lunar dust isn't just a thermal threat, it's an airborne contaminant. Every microscopic particle is jagged, like shattered glass. If it enters the air loop, it can shred seals and mechanisms, and damage delicate lung tissue over time. Every single breath must be fought for, or the lungs fail. With energy and air flowing, the organism needs blood. Water is heavy and extremely expensive to ship from Earth, so the base must recycle everything. Every drop of moisture the human body releases is captured by the habitat's recovery systems, filtered and purified. Today's sweat becomes tomorrow's coffee. Current life support technology can reach recovery rates of around 98%, but recycling is never perfect. Even with the best systems, tiny amounts of moisture escape into the vacuum. Day by day, drop by drop, the organism is slowly bleeding out. To survive long-term, you cannot just recycle, you have to replenish. That is the exact reason Artemis targets the lunar South Pole. The extreme, -200-degree cold that threatens the base is also what preserved ancient water ice in the shadowed craters. By mining this frozen dirt, we might finally replenish what the organism loses, keeping its bloodstream full. The organism has a pulse, breath, and blood. Now, it needs a stomach. You can't sustain a crew for years on imported rations alone. The weight would bankrupt any supply chain. The base must grow at least part of its fresh food, and eventually, its own calories. In a closed loop, there is no such thing as garbage. The base must digest its own waste. In the gut of the habitat, bacterial bioreactors take human waste and inedible plant matter, breaking them down into nutrient-rich liquid fertilizer. This liquid is continuously pumped into towering, soil-free hydroponic farms. Why go through all this trouble? Why not just plant seeds in the lunar dirt? Because lunar regolith is not real soil. It has no organic ecology, and it's laced with reactive compounds and heavy metals that chemically poison roots. Plants can germinate, but they struggle and stunt. You can't farm the moon, so instead, the gut builds its own ecosystem from scratch, fed entirely by the waste of the people it keeps alive. The organism is now breathing, pumping, and digesting, but on the moon, there is no magnetic shield. The surface is brutally exposed, from constant galactic cosmic radiation to violent solar storms. These invisible high-energy particles pass right through standard metal walls, depositing energy into human tissue and causing complex DNA damage. To survive, the base needs a thick skin, and it uses the very thing that has been trying to kill it. Future habitats may use robotic systems to print meters of lunar dirt over the modules, alongside walls filled with recycled water to scatter and reduce the radiation. The dead, abrasive regolith that choked the machines and poisoned the plants now becomes its ultimate armor. But protecting the physical body isn't enough. You have to protect the mind. That is why those glowing hydroponic farms aren't just there for calories. In a world of deadly radiation, grey dust, and eternal shadows, the human brain desperately needs the smell of a green leaf and the feeling of an Earth-like day. The mind needs something alive to hold on to, because what comes next will test everything this organism has built. In a tightly coupled habitat, one major failure can trigger a cascade. Power drops, pumps stall, thermal control slips, water freezes, the lungs choke. A cascade like this doesn't take weeks. It kills in hours. That is exactly why a lunar base cannot just be designed as a building. It must be engineered as an integrated survival system, built on buffers, redundant loops, and backups. A place where waste becomes food, dust becomes armor, and every single drop of water is sacred. The moon does not forgive mistakes. It will remain a dead, silent rock, whether we go or not. But learning how to keep ourselves alive in this fragile loop might be exactly what teaches us how to protect the ultimate life support system we already live inside. Earth.